So innovation session here, but what I'm kind of going to present here is a simple problem with a simple solution, hopefully that I think probably affects a lot of people in this room. And I will just walk you through how we've approached it. So the problem that I'm laying out here today, we have a new CEO, started a couple months ago, and one of the things we need to do is report the results that have happened in our organization to her. And we have a lot of athletes, a lot of teams at US Ski and Snowboard, and difficult to get all of those results into one spot, particularly for someone who's not familiar with all of our sports. So how did we do that? This symbol on the right is supposed to be a CEO, in case you were wondering. The one website we primarily deal with is the FIS website, which aggregates international results. If any of you have one website you go to on a daily basis, which is kind of a pain, you will feel us. So a lot of PDFs, a lot of results in difficult formats. Well, we called up Zach, and Zach Cross works for Smartabase. He's out of Australia, and he was nice enough to write us, I say simple scraper, but it was a more, it was above my capabilities of a web scraper. So Zach wrote us a nice script, and we've actually had to adapt it a couple times to, it originally was scraping from a FIS mirror that we had set up, but we went directly to the URL eventually. And now this is what we have. We have an aggregated set of results that we're able to run a simple report on every Monday morning. These are from a couple weeks ago. Nice first place in there with the #1 World Cup of the year, all publicly available data. So good to see there. And now these go right to the CEO every Monday morning and all automated and out of our hands. How else is this kind of methodology applicable? Well, it's basically any website you go to on a daily basis, or anything you want to overlay with your athletes to give better insight into your data. So the way I think about kind of using Smartabase is we have medical data, training data, outcomes, and how can we layer all those and make insights? Well, one thing all of our teams around the world have, they have different weather, and that is a big variable in our sports. And generally right now, we just import weather manually or not at all. But it would be nice to have kind of a standardized automated system. So what I'd like to do next is set up a scraper to look at the weather for each of our teams around the country, and then you're able to say, what results did we have in a various weather condition, and maybe if we're during precipitation, maybe results aren't great, we can go back and look into our training data and say, how many times are we training in that particular weather condition before a competition? And that's how we can kind of impact going forward. That's all I got. Thank you.
Thanks, Gus. Next up, we have Travis Valantes, the case study, University of Texas.
Thank you. Very similar problem to what Gus outlined. Apparently, getting results of the things that you do every day is inherently difficult across different organizations. So our problem was, how can we take all of the performance data that we collect in the sports science department, for a variety of reasons, make better use of it, make better decisions about what equipment we're purchasing, how we're spending our time testing athletes, by connecting it to their actual on-field performance data. So really brief background. For the last 5 years, we've collected a lot of performance assessment data and a lot of athlete monitoring data. The performance assessments are things like body composition with DEXA, movement screens, force plates, sensory motor ability, all of those types of things, and those battery of tests are catered to the sport demands. We have 500 athletes across 16 sports, so there's quite a bit of variation in exactly what tests they're going through. But we do now have a pretty good data set after doing it for 5 years. So we'll test about 1,300 athletes over the course of this school year. So we're now to the point where we have a good amount of data. Same thing with the monitoring side. We'll do things like wellness and RPE, and collected those over the last 5 years. So how can we take those big data sets and really now go and outline, okay, here are the conditions in which we measured you were in for your sport. How did you then go and actually perform? So that allows us to do a whole bunch of things, mainly just make better decisions about are the things that we're measuring from the sports science side really connecting and relating to what's going on in your sport. In this case, we wanted to start with swimming and track. So some of the individual sports, obviously much easier to quantify performance there as opposed to doing something like a team sport. So it's really just benchmarking the peak physical performances, looking at physiological and psychological characteristics when those performances occurred. But we didn't have a lot of that data. The media relations department, they have to make sure that they report it a certain way. It's actually like an old MS-DOS program that produces a PDF report that's standard across the NCAA. So it's not very efficient for their time to be able to go do it. So we thought, okay, we can develop a web scrape. All of this stuff is available online. We'll just go ahead and do that in-house. So one of our sports science professionals, Tommy Evans, was able to kind of put all of this together. None of us are data scientists by training, but through the power of YouTube tutorials and asking friends and things like that, he was able to develop the R script that could go and scrape these results for us. Again, we kind of developed that in-house, so it's a little bit different than Fusion doing it for us. That gives us the advantage of, as we go to expand this from just, say, track and swimming to now our team sports, so we're getting all of our basketball, volleyball stats, things like that. Now it gives us the flexibility to be able to adjust that script for different websites as we have to go track down that information. So just some samples of kind of what that looks like. So what are we able to do with that information? The quadrant graph that you see there, that was one of the key pieces. So we take all of our athletes' all-time results while they're with us, and even back into high school, we've been able to scrape and say, okay, we're going to rank your performances as a percentage of your personal best, percentage of the best on our team, and percentage of the best in the NCAA that year. So we have several different layers of ability level. And we can start to make decisions about, we have our performance metrics, we have your in-pool metrics in this case. Are you really good physically but not great in the pool? Okay, maybe we need to increase the amount of time we're spending in the pool. It's more of a sport skill acquisition problem than it is a physical attribute problem. So it allows us to really kind of break athletes down by that, which is what that graph is. It also allows us to overlay other information with their performances. So again, just looking at what was going on with the force plate around your best performances, what was going on with your wellness questionnaires, your RPE, how were your training loads the week before, did your taper go well? All of those insights can be gained once we actually have all of those longitudinal results over time. Future development, so something that we've already started working on and we like to expand on. We've web scraped for the NBA Combine data. So all of our men's basketball players go through the same combine testing that they do there. We're able to pull that data for, I believe we went back to 2017 for this. Now we can give our players true context. So you see the Texas overall performance score is our aggregate performance assessment. And then we can also give them what they would score at the NBA Combine for their position. We can also give them feedback on, okay, this is where people have been drafted in your position over the course of the last 2 or 3 years. So it allows us to inform our guys of trends that are happening in the NBA based on who's getting drafted and what they're seeing that way. So it's been a great tool for us in terms of connecting that sports science, more assessments and monitoring information with what actually goes on in the sport, talking the coach's language, and then feeding it back to the athletes.
Perfect. And then just sort of expanding on from the Fusion perspective where our data science consulting is now going. Fusion Sport is still developing a long-term data science strategy and will be shared with clients soon. Current strategy is a deliberate, slow and collaborative approach with our clients. Customers are going to be heavily involved and have some internal resources to learn, develop and deploy. Reusable workflows, code, documentation will have support, will be prioritized over bespoke workflows. And we're looking to build tools to empower the customer rather than continue to build niche workflows. And I think Deutsche is going to expand on this a little bit in his closing address. And now moving on, we have Andrew Murray, for the NBA Orlando bubble.
Thank you. Nice segue from Combine to spending 100 plus days at Disney World, which isn't as fun as it sounds. So context around March, the first positive COVID test ended up shutting down the league. And then in July the same year, 22 teams came to Orlando. 100 plus days later, we were able to crown a champion and finish the season. And what this session or this portion is about is how do we use integrations and different pieces to try and make sure that everyone got in and got out and was healthy in the process. So collating all the health information and integrating inputs from a number of different partners. And then crucially, allowing people to move around the campus. So we heard a lot about the fire solution and how they're using daily health checks. We had all the same sort of stuff with some little other additions. So every morning within your room, every person on campus would open their app, would complete their health questionnaire. We also had some other pieces into that health questionnaire, such as a temperature, pulse oximetry. What we didn't want was people taking their temperature, is your temperature above 100, and then lying about the answer. So we had to find a way that that temperature went directly into the app and didn't allow them to edit the response. I'm not suggesting that players would lie, but you never know. And the same with the pulse ox, how do we do the same thing? How do we manage to keep all that together? And then crucially, with our daily testing, how do we integrate that into the access control? So as people move about the campus, if their health status is less than optimal, we can control where they can get to. So they can't get to the practice courts, they can't leave their room, they can't go across or between the 3 different hotels or the arena that we had. The way that worked, you can see in that bottom picture is the Disney Magic Band. So the Magic Band, if you're on campus, if you've ever been to the theme park, is what allows you to move around. You can charge that up with cash, you can use it to buy food, drinks, concession stands, or it's your room key for your hotel. So people don't lose it. Everyone on campus had a Magic Band, and they were customized with your team. They were labeled to you on your name on the back. And what that allowed us to do was integrate all those different pieces of information. And as test results came back, if there was a inconclusive or a positive test, that would change your health status. And so your access was controlled. You can't get to different areas. And what that allowed us to do was, or Smartabase allowed us to do, was take all those inputs and then work with Disney to integrate that without sending anything other than controlled health information, anything other than their status. We also pushed it to different partners and different ways of doing it. So the whole process from start to finish, we had these direct integrations with a Bluetooth thermometer, the pulse oximeter, the questionnaires that, as we spoke about, which went into the system, fired alerts, and allowed us to do reporting or real-time access. Example of that, if someone completed their health questionnaire and had headache, sore throat, one of the symptoms, the doctors who are on campus and responsible for the health and safety of non-playing staff, and not players, not team staff, how could they triage that? How could they go and help and find the individuals who needed to follow up with their health status? So as we said, all that comes into the Magic Band, and that allows you to move around. So in total, there's over 3,000 people. We also used it at the same time. This was the bubble in Orlando, the wobble, which was happening down the road at IMG, the Women's League, WNBA. Very similar process, but different testing partner. But everything else the same. So how do we do that integration at the same time? And you see a hell of a lot of questionnaires, a hell of a lot of COVID tests over the course of those 100 days. So where does that go? We can do it in other places, access control. We've now taken this, as we said, we did it with the women. We've also done it in Africa. We just launched the first Basketball Africa League. It was just not so long ago in Rwanda. So over that, we did exactly the same, but with a different testing partner, a different location, and managed to control the access. And again, got through and crowned a champion. So all those things are there. If you want to talk about that, I'm around and come and ask questions.
Perfect. Thanks. Thanks, Andrew. And next up, we have Stephen.
Hi, I'm Stephen Saddam of Algovation. I consult for DevCom, and I do a lot of work with H2F as well, so I'm going to present some of that data. So the problem is we have these capabilities to do modeling in R, and then we have Smartabase, but they're not really connected. So there's a way to push it up through the Neon package and through some of the conversation we had earlier from our two first presenters. What I was trying to do was do some cluster analysis, which basically takes multidimensional data and gives recommendations. For H2F, we're looking at who are the lower performers for the physical assessment tests, the ACFT or APFT. It was a variation of it. And for the OHWS, the Operators as Human Weapon System program, we wanted to see what were the most influential variables for some of their self-reported outcomes. So looking at the cluster analysis, we had a modification of the ACFT. It was 5 different exercises: the mile run, deadlift, pull-ups, bodyweight bench, standing power throw. This has been graphed onto one-dimensional data or two-dimensional data, so you can see it in a flat graph, but it accounts for all 5 of those. You can see the graph on the left is the green. Those were your high performers. They had a lower mile time, higher deadlift, better pull-ups, better bench. And then on the far right is cluster 1. Those were your lower performers. What's great about this is once we run this analysis, we can actually push that data up to Smartabase, put it in their profile, and then your frontline leaders who are in charge of PT can say, okay, group 1 over here, group 3 over here, and you can modify your training based on that. So we were talking about the pitchers and what were some of the variables that made their pitch speed go down over time. And we kind of had that same idea. We had self-reported data of their overall performance, their self-assessed physical performance, mental, and emotional. And so what we did was we did what was called an elastic net regression. It basically gets rid of all of the data that is unnecessary. And Adam Strang referenced variable reduction. It's very important. It reduces the burden of computational time, as well as also removes having to look at 1,000 different data points to get to one solution. So for this, we were looking at overall performance, and what we ended up seeing was that change in heart rate from your 28-day average to your last night average was the most influential of your overall performance. While if you actually look at activity, the previous day's activity had very little, if any, influence on how people felt they were going to perform the next day. And then again, we can push this up to Smartabase. After running this model, we can push that data up as either predictive or surrogate data, because some days we didn't have the AM check-in, therefore we didn't know what that person's status was. If we wanted that commander to know what the status was of his whole unit, but half the people didn't fill it out, well, we could fill it in with this modeled surrogate data, and that way we could see how many reds, how many greens are ready to go for that day. So the second problem was having high frequency data and doing that kind of data analytics, but what if you don't want to have R on your system? Earlier on, he said, we're not all data scientists, and knowing that we can create web applications in a program called Shiny. And it's a web-based application, and you can also embed algorithms on the backside to, as a data scientist, reduce the burden or reduce all the software from somebody else's local PC and just have a web-based instance running. So for this study, it's not even a study, it was we were trying to get a breathing cadence for optimal meditative reconditioning. So just with a Polar H10 heart rate strap and an app that collected raw data, you could do a breathing cadence and find out what how fast your heart rate variability dropped down to 0 and what the peak spectral density is. Don't worry about what that means, but it's simply a number that is output from this metric. So the higher the peak spectral density, the better that cadence is for you. And this way, an individual can optimize their breathing cadence to get into that relaxed state as quickly as possible. So you could just download it, open up this Shiny app online, upload your TXT file or your CSV file, whatever came out of your application, and it'll dump that data to you. Ideally, you can even have this connected to your Smartabase app. So then not only the user can see it, but the clinician who is actually working with that person for that meditative state can look at it too and walk them through what this means and how it benefits them. So this was looking at one cadence. This is looking at a different one. Obviously, very quickly, I got into that relaxed state. The second one is the better one. So lastly, we did some polar flow algorithm development. If you've ever used Polar Team Pro, you know that once you start collecting, it's one giant data set. Well, we were running a whole bunch of sprints, followed by rest time, followed by a whole bunch of sprints. So I built an algorithm on the back end. You could just download the entire data set from that individual for the whole day. And what this does is it breaks it up into these data segments. So we have the sets of 6 sprints that we knew were coming. And then we plotted, you see the little data point at the top, what that peak speed was for each of the sprints, as well as the corollary heart rate. Then all of that data can actually get pushed up to Smartabase without actually having to manually separate out each one of those runs in the Polar app, downloading it, processing it on the CSV, then trying to upload it to Smartabase. So this saves an infinite amount of time. But the issue right now is Shiny cannot be run currently with Smartabase because they need to host a web instance of Neon. We've been told through this conference that they're going to be doing that shortly. And that allows for a completely automated system where you don't need a data scientist on staff. You just have this built one time and you can have people upload data. Also, we can do further automation of the R package by uploading those initial R packages or those R scripts that I had shown you. We can put that on the Smartabase cloud server, and this can run automatically. Those models can be filling in gaps in data whenever you need it.
Thanks, Stephen. Alrighty, guys, I just wanted to touch on some Smartabase, innovations in this respect to tie things up. Building on what Marcus said yesterday, it's a very exciting time to be a part of Fusion with, the expected growth and scalability of the company has come a lot of, internal reflection with respect to the core ideologies that sort of underpin our philosophies, and innovation certainly aligns with what we're trying to do here. It's interesting, in a sporting context, innovation is not necessarily sort of synonymous with invention. I think Georgia touched on it yesterday really well. There's a bit of a sort of cultural predisposition to adopt new and emerging technology, and sometimes that's at the behest of doing the basics right. And at the core of innovation is not necessarily, as I said, invention, but it's more sort of positive change. And positive change can be on a small scale and it can be on a large scale. So what I'm going to talk about today, as I said, is the Bluetooth Scales integration. We've actually got it out in the lobby if anyone wants to check it out afterwards. So really basic problem. Manual data entry, as we know, it's arduous, it's inefficient, prone to human error. Obviously, we're in the age of digitization. We should be recording things digitally and getting away from pen and paper. The solution, hopefully this video is going to play. Click it. Oh, there we go. So what you're seeing here is just the kiosk app, and as I said, this is out in the lobby. You've got the player logs in, or the coach connects to the scales. As you can see, it's connected there. And then we're going to go back into the kiosk interface and record weight. And the weight is Bluetoothed digitally in, as you'll see shortly. So you can't actually hear this, but I'm about to step on the scale. Looking a bit heavy there, and going through. Perfect. So look, super simple solution. I think the benefits are indicative. Look, automation, digitalization, this is exactly what we're here to do. Obviously, it's an integration. It's going to take away those manual, arduous steps. We have seen sort of this mode sort of compound compliance in a setting. Obviously, athletes like to play with tech, and having this sort of tech can help. And obviously, the biggest part is also feedback. We're giving feedback to the athletes in real time to a degree. I think the really cool thing about this is obviously this can tie in to the other, I guess, the sort of the framework that underpins Smartabase, that flexible framework. So with this being sort of digitally added, what you can do is then run any concurrent calculations straight away. So obviously looking at, mass change when you weigh in, weigh out, or, taking it to the granularity of, looking at sweat sodium concentration, mass change, and then prescribing sort of how many of a certain drink to recover post. And then just some details about it specifically. That's the model that we've integrated with. It's roughly about 650 per unit. And it's in the final beta stage of testing. So if you guys are interested, please sort of reach out to your Fusion support representative and they'll be able to help you out.